For the first minute, imagine, if you will, a freezing night on the Eastern Front, a frostbitten bivouac, with soldiers huddled together in mud-soaked trenches. Fuel was incredibly scarce. Tents offered only the barest protection, and conventional stoves were either much too bulky or simply unavailable. Yet some soldiers had access to a tiny portable heater, made almost entirely from ash, that could warm an entire squad for hours on end. This was World War II's pocket heater, a marvel of ingenuity, really, that transformed a common byproduct of fires into a highly efficient source of heat. It wasn't glamorous, it wasn't high-tech, but it was reliable, portable, and honestly, incredibly effective. Understanding how it worked gives us insight not only into wartime survival, but also into low-tech heating solutions that anyone can apply today. The pocket heater was created to solve the problem of heat scarcity in frontline conditions. Soldiers in World War II faced, some of the most extreme conditions imaginable. On both the eastern and western fronts, winter temperatures plunged well below freezing. Fuel shortages were unfortunately common, and transporting wood, coal or coal briquettes to forward positions was dangerous or quite often impossible. Traditional stoves were simply too heavy for rapid relocation and required constant feeding. Engineers needed a solution that could provide reliable heat with minimal resources, be portable enough to move with a unit, and be safe enough to use in confined shelters or trenches. The solution was, surprisingly, rather elegant. A small, self-contained heater built from ash, the residue of previously burned wood. Ash itself is lightweight, widely available, and when compacted and treated correctly, can retain and radiate heat for extended periods. Soldiers could construct these heaters right there in the field, using minimal tools and resources, yet benefit from warmth that lasted hours without any need for additional fuel. The construction relied on basic principles of insulation and heat retention. The pocket heater consisted of a simple cylindrical or rectangular container filled with compacted ash. Soldiers would often use discarded tin cans, metal boxes, or small wooden frames lined with metal. Layers of ash were carefully packed to eliminate air gaps, then sometimes mixed with a small amount of sand, clay, or salt to increase density and stability. A small combustible core, often just a few embers from a previous fire, was inserted into the ash, which acted as both a fuel reservoir and an insulator. Ash has, remarkable insulating properties. When tightly packed, it slows the transfer of heat while allowing slow, even radiation. The embers burn gradually, producing a steady release of warmth, while the surrounding ash prevents rapid cooling. Even in freezing temperatures, a well-prepared pocket heater could maintain usable heat for an entire night or for the duration of a sentry shift. The heater's portability and efficiency made it invaluable to soldiers. Unlike larger stoves or open fires, the pocket heater could be carried in a pack, deployed quickly and used in a variety of shelters, dugouts, tents, or even inside vehicles. It produced no large flame, reducing the risk of enemy observation. Because it relied primarily on ash and a small ember core, fuel consumption was minimal. A single handful of embers could sustain warmth for several hours, and additional ash could be compacted around the heat source to extend longevity. Soldiers quickly learned to optimize the design. Placing the heater in the center of a small enclosed area increased efficiency, as radiant heat reflected off walls or canvas. Adjusting the ash density allowed control over the burn rate. Covering the top lightly with metal or cloth could further concentrate heat without smothering the ember core. This flexibility made the pocket heater a versatile tool in conditions where traditional fuel or stoves were unavailable. The pocket heater also improved survival, comfort, and operational efficiency. Cold exposure in winter campaigns caused frostbite, hypothermia, and reduced morale. The pocket heater allowed entire squads to maintain body warmth during rest periods, reducing illness and improving readiness for operations at dawn. Unlike a traditional fire, it did not require constant tending, reducing the risk of neglect in dangerous conditions. It could also be used to dry small items of clothing or socks, further enhancing soldier comfort and hygiene. Field manuals and soldier diaries from multiple fronts mention improvised ash heaters in rural winter operations. While they were simple to make, the principles of insulation, controlled radiation, and slow-burning fuel made them remarkably effective. They highlight a broader lesson in survival engineering. Efficiency often comes from understanding materials and their properties, not simply relying on high-tech solutions. Modern survivalists can replicate the World War II pocket heater with simple materials. To build a contemporary version, start with a small metal or ceramic container. Fill it with compacted ash, optionally mixing in a small amount of sand or clay for additional density. Create a core of embers from a previous fire, charcoal, or small, slow-burning wood pieces. Then carefully insert it into the ash. Adjust the packing density to control heat output. For safety, place the heater on a non-flammable surface, maintain ventilation, and use reflective barriers to direct warmth to people or objects nearby. This method provides lightweight portable heat that can be used in tents, shelters, or temporary encampments. The key principles, using ash as both insulation and fuel medium, controlling heat radiation, and maximizing portability, remain entirely relevant for modern survival, camping, or off-grid scenarios. World War II's pocket heater is a testament to practical ingenuity under extreme conditions. It demonstrates that some of the most effective survival tools are low-tech, resourceful, and based on a deep understanding of materials. Soldiers didn't rely on luxury or convenience. They relied on what was available, and they engineered solutions that saved lives. Today, recreating this technique offers practical benefits for anyone interested in historical engineering, survival skills, or efficient heating methods in austere conditions. If you want more deep dives into forgotten wartime innovations, survival tools, and practical historical engineering, make sure you subscribe to Backyard Wisdom, share this video with fellow enthusiasts, and help preserve this essential knowledge for future generations.